Okay, this is number 10, part C and D, so continued from the last video. Here we go. If the cart were instead given an initial speed of 3 meters per second up the incline from the base, how far up the ramp would it go? So now we're thinking about that we are starting the box at the bottom, we're giving it a shove, and it's slowing down as it goes, and we want to find out where is that moment where it comes to a stop. We want to know how far up the ramp would it go. I want you to consider, kind of like I described on the last problem though, that thinking about this in a horizontal sense works the same. We found that there's an acceleration, which is 2.58 meters per second squared. So if we were to give this box a shove, some initial velocity, and that was the acceleration bringing it to a stop, where it reaches 0 meters per second, like it's scraping across the floor with friction slowing it down, which is in fact what's happening here, then we have the same problem. This is just a kinematics problem here. So to solve this problem, I'm going to choose the equation velocity squared equals initial velocity squared plus 2 times my acceleration times my displacement. I'm going to think about what are the variables that I already know. My final velocity is going to be 0. My initial velocity is going to be 3 meters per second given in the problem. My acceleration I found in part A of this problem, 2.58 meters per second squared. And the value that I want to find is my displacement. What's left out? Time. So I'm looking at, that's how I selected my equation. And now we'll go ahead and use it. So when I go ahead and do my algebra, rearranging this equation, and then I'll put it over here, I've got that my displacement of my object is going to be final velocity squared minus initial velocity squared divided by 2 times my acceleration. So at this point, I'm just going to plug in values here. I've got 0 meters per second squared minus 3 meters per second squared divided by 2 times my acceleration of 2.58 meters per second squared. I'm in my denominator right there. So when I plug all that in my calculator, I get that my displacement is 1.7 meters. And that's describing how far along the ground, which includes, great, if we tilt my head sideways, that's how far up the ramp it goes. For part D, how much time elapses? Oh, hey, how interesting. Time was left out of our previous problem. And now we want to use the same information, or we can use the additional information of our displacement we found to figure out how much time it took for it to do that. Now there's one more, oops, the careful, danger, whatever, right here, which is before it returns to its starting point. So I'm thinking about how much time does it take to go up and how much time does it take to go down. The object is going to experience the same acceleration throughout that entire trip. So instead, there's more than one way that you could solve this problem. I'm going to do one, the easiest one from my perspective, which is I'm going to use the equation for final velocity equals initial velocity plus acceleration times time. I'm going to leave out that distance. I'm going to find the time for it to reach 0 meters per second, which is going to be a half trip when that final velocity equals 0. And then I can take my answer times 2. You could also use this where you include the displacement we found in the last problem, and you say, well, what about if that distance is doubled? So when I take this, here we go. It's just that easy. I do my algebra. I've got the time. It's going to be equal to the difference between my two velocities divided by acceleration. And then I'm going to take that number times 2. So I want to know what 2 times the time is. So I've got 2 times 0 meters per second minus 3 meters per second divided by my acceleration from part A, 2.58 meters per second And you'll notice you end up with a negative sign, right? So we can think about the diagram that we drew above. If I'm considering a displacement this way, and I just treated this as if up the ramp was a positive velocity, well then my acceleration is technically down the ramp, which makes that negative. So when I plug all this into my calculator, I get 2.33 seconds is how much time it takes for that block to go 1.7 meters up the ramp and 1.7 meters down the ramp.